So sorting means it is a problem to rearrange the items of a given in ascending or descending order. The searching problems deals with finding a given value called search key in a given set. The word algorithm is a set of rules for carrying out some calculations either by hand or a machine. An algorithm is a stepwise representation of a solution to a given problem. Hello everyone, welcome to the session 1 of the unit 1 of the subject Design and Analysis of Algorithm. Today we are going to study about introduction of the algorithm. My name is Chandana C, faculty of BCA, Vidhyaashram, first grade college, Temple of Excellence, MYSURU. Come, let us have a look into a agenda of today's session. Today we are going to know about what is algorithm, then what are the fundamental algorithmic problem solving. Next is fundamental of the analysis of algorithm efficiencies. Next we have analysis framework, measuring the input size, units of measuring runtime, order of growth, and at last we will come across worst case, best case and average case analysis. Let us move into the first introduction, that is what is algorithm. Here we have the word algorithm is a set of rules for carrying out some calculations either by hand or a machine. So algorithm is what? It is a step-by-step procedure, or we can say it is a set of rules. Why we need set of rules? To carry out some calculations. See, for example, if I want to write algorithm to find the addition of two integer numbers, I can write through hand. I have step 1, that is I need to start the algorithm. Next, I need to write step 2. I need to take the input, isn't it? What are those? So, input A and B. These two are non-negative integers, that they must be positive integers. After inserting A and B, I need to read. So, in the step 3, I am reading. Read A and B. After reading this, what is my problem? I need to find the addition of two integers, isn't it? So, in the step 4, I am performing the addition operation, that is add A and B. So, after adding these two numbers, I need to store the addition value to some other variable, isn't it? That's why I am taking here sum is equal to A plus B. After adding in the step 5, I am going to return the sum value. Step 6, stop. I completed my addition, isn't it? I calculated by adding two numbers. So, my algorithm completed. So, in the step 6, I wrote stop. I stopped the writing of algorithm. This is how we write the algorithm. That's why we say it is a step-by-step procedure or a set of rules for carrying out some calculations. Now, let us see how this algorithm works. See, whatever the input we have given to that, it should have some set of rules to obtain the expected output from the given input. Here I have given the input as two integers, that is a non-negative integers. So that's why I am getting a output in a positive only, that is a non-negative. The output is a negative. Okay, that should be positive. So whatever the input you are getting, the exact output should be get. So this is how our algorithm works. Next, we will move on to the important problem types. So that some important problem types, we are going to use it in our algorithms to solve many other algorithms which are coming under the next unit. So firstly, we have sorting, then searching, string processing, graph problems, combinatorial problems, geometric problems, and numerical problems. So these are the some of the problems now I am going to discuss. So we need these problems to solve the some other algorithms in the upcoming units. That's why I am going to discuss here. Now I am going to discuss about the some important problem types. Firstly, I have a sorting. So sorting means this is a problem to rearrange the items of a given in ascending or descending order. Ascending or descending order. So what do you mean by ascending order? So as we all know, we can arrange the ascending order means from increasing, isn't it? From 1, 2, 3, 4, 5 like this. Descending means 5, 4, 3, 2, 1. So this we call it as ascending or descending order. Next, sorting can be done on numbers, characters, strings or records. To sort student records in alphabetical order of names or by student number or by student grade, point average. So such specially chosen piece of information is called key. So we call it as a key. For example, if the 10th standard results are out, so we need to rearrange the students. We have lack of students, isn't it? The whole India has a lack of students whose results are outed now. So we need to rearrange from the grade A plus, then A, B plus, B. So like this in the descending, from the descending order. So we need to arrange it. So we have a key to, so those who have got the A plus, so arrange those names first. Those who have got A, then arrange next to A plus students. So like this, we are arranging here in the descending sorting technique. So for example, in which are the algorithms we are going to use? Example are selection sort, quick sort, bubble sort, insertion sort and merge sort. Next, we will move on to the searching. So searching means what? Something we are searching. For what? So in a cupboard, if I want to search for a pen or a cloth, anything, we will search it sequentially, isn't it? One by one rack after the other. So like that, the searching problems deals with finding a given value called search key in a given set. For example, if I have a array list 2, 5, 7, 3 and 4. Here I have a 5 elements. I need to search for key element 1. My search element is 1. That I am saying here key. So that is 1. So by seeing only I can tell 1 is not present, isn't it? But in the algorithm, it goes on searching. It searches for the first element, then it moves to the 5, next element, then 7, then 3, then 4. So one by one, sequentially it searches. So if 1 is not present, after end of the array, last element, it gives the output element not found. Element not found. If instead of 2, I have entered 1 in a list. So initially only I will get the 1 in the first position only. So then it gives the output as element found at index 0 like that. So example, ordinary linear search and fast binary search, we are using this searching problem. Next, we will move on to the string processing. So what do you mean by string? So the word or the word which we are writing within a double quotes. Example C, 1, 2, 3 at DAA. So this is my string. It's a sequence of characters from an alphabet. String comprises, it contains letters, see, only letters, or it can contain numbers like 1, 2, 3 and special characters like @ symbol. Searching for a given word in a text is called string matching. For example, if I take 1, 2, 3 at DAA, I want to search for this word DAA. Yes, I can search. If it is present in a given string, it gives output as your word is matched like that or else not found. Next, we will move on to the graph problems. A graph is a collection of points called vertices and which are connected by a line segments called edges. So the collection of points is nothing but all of us know graph means it contains nodes or vertices like this, 3 or more. So how much you want, you can take that based on your problem. I have your 1, 2, 3, that is A, B, C are my nodes. Node 1, node 2, node 3. So I have the connecting line from A to B, B to C and C to A, isn't it? So these line segments are called edges. These line segments are called edges. So if this graph has a arrow mark like this, if it has a arrow mark, then we can say it is a directed graph. We can say directed graph. It's showing the direction. You should move from A to B, B to C and A to C. Directed graph. If it does not contain any arrow marks like this, then it is called a undirected graph. Undirected graph. Hence, we can move from A to C or C to A or A to B or B to C. So, some of the graph problems are graph travels, shortest path, topological sort, traveling salesman problem and graph coloring problems. So, these problems we will discuss later in the upcoming units. Next, we have geometrical problems. These algorithms are methods used to solve problems involving geometric shapes. So, example, line segment intersection. Next, we have a combinatorial problems. So, these problems that ask explicitly or implicitly to find the combinatorial object such as permutation, combination or subset. A desired combinatorial problem may also require to some addition property. So, we should find the maximum and minimum. So, as I said in the graph, directed, undirected. So, it also contains the weight. Say for example 5, 4, 3. If you have written a numbers on the edges, it means it is a weighted graph. If you want to find the minimum cost graph or maximum value, so based on this we will use a combinatorial problems. For example, travel salesman problem. If you want to visit all 3 cities within a minimum cost. So this is an example for combinatorial problem. Next is a numerical problems. Numerical problem algorithm is a step-by-step procedure. It is designed for solving mathematical problems using numerical methods, which often involve approximation. These algorithms are essential finding solution to problems that are difficult or impossible to solve analytically. So hence we will use the numerical problems. So these gives the step-by-step verification. These are some of the important problem types. Next we will move on to the use of algorithm. In the last 2 sections we studied what is algorithm. So how we are going to give the set of rules to work the algorithm. Then we come to know what are some of the important problems we are using to solve the algorithms. Next, we will move on to the use of algorithm. So, what is the use? So, we have different fields. So, some of the areas, we can say areas also. So, where algorithms are used. So, firstly, computer science. So, in the computer science, mainly we are using. These are the basis of computer programming and are used to solve problems. So, ranging from simple sorting and searching. Then to the complex, that is artificial intelligence and machine learning. In the computer science, the basic is algorithm, from a simple one like sorting, searching, to the complex one, that is artificial intelligence and machine learning. So till that we will use the algorithm. So next is the artificial intelligence. So these are the foundation. Algorithms acts as a foundation for the artificial intelligence and machine learning. They are used to develop intelligent systems that can perform image recognition, natural language processing, and decision making. So like today we are using Siri, Alexa, and the robots to serve the food in the hotels, etc. So before getting to the program, they are writing the algorithm. So in the artificial intelligence also, the algorithm is used. Next comes in the field of mathematics. So it is used to solve the mathematical problems like finding the optimal solution system for linear equations, then shortest path in the graph. Next is the operation research. Algorithms are used to optimize and make decision fields. Which are the fields? Such as transportation, logistics, and resource allocations. Next, the data science. Algorithms are used to analyze, process, and extract insights from large amounts of data fields such as marketing, finance, and healthcare. So in these fields, we are using the algorithms. So next comes, what are the characteristics of algorithms? So what are the characteristics of algorithms? We should have some well-defined inputs to get the well-defined outputs. Next comes, it should be clear and ambiguous. So whatever the input is giving, that should be clear and ambiguous. Then that input should be language independent. Next, whatever the output you are giving, as I said, well-defined outputs. If we give the well-defined inputs, we should get the well-defined outputs. That should have some finiteness and it should be feasible. So these are some of the characteristics. So let us now discuss one by one. Algorithms are characterized by their ability to produce specific outputs from defined inputs that should have a clear and ambiguous steps and terminate after some finite number of steps. So let us now discuss one by one. Well-defined inputs. With well-defined inputs, it is easier to optimize algorithm based on the characteristics of the input. Next, we are getting well-defined outputs. The output of an algorithm should be well-defined, that the algorithm produces the intended and accurate result for a given set of inputs. Clear and unambiguous. It allows algorithms to predictable, that is, same input should produce the same output. Next characteristics is finiteness. Should end after some finite amount of time and it should have limit number of instructions. So if I give a limited, so for example, I have taken a plus b, right? So why I took only two numbers or two integers? Because I need to add only two integers. That's why I am taking two, a and b. Why I need to take c? That is simply waste of time and space, isn't it? This is one. It makes a confusion for the system also. Why this c? From where does it come? Why they have taken, isn't it? So if I want to add two integers, I just want a and b. That's it. Next, the language independent. Language independent algorithm can be easily ported to different programming languages and platform, making more adaptable and usable across various environments. So whatever we are writing the algorithm, that should be language independent. It should be ported to different programming languages and platforms. Next, effectiveness and feasibility. Algorithm must be simple, generic, and practical. So it can be executed with the available resources. So these are some of the characteristics of algorithm. Next, we will move on to the properties of algorithm. It should terminate after a finite time. It should produce at least one output. So, if I giving a one input, at least it should produce one output. Next we have, it should take 0 or more input. The algorithm, what I am writing, it should take 0 or more input. Next, it should be deterministic, means giving the same output for the same input. If I am giving a positive integers as a input, then it should give a output in the positive only. The output should be a positive integers like this. Output for the same input case. Every step in the algorithm must be effective. That is, should be do some work. If I am telling read A and B, it should read. If I am telling sum is equal to A plus B, yes, it should do addition of two integers. Like this, every step should be do some work. These are some of the properties of algorithm. Next, we will move on to the types of algorithms. Firstly, we discussed regarding the problem. What are the different problem types that we are using in algorithms? Now, we are going to discuss different types of algorithms. So, there are several types of algorithms available. So, in those, we are discussing about the important algorithms now. Brute force algorithm. So, it is the simplest approach of the problem. What is this? Simplest approach. Brute force is the simplest approach. A brute force algorithm is the first approach. So, always we approach, initially we approach brute force approach. So, that comes to finding when we see a problem. Hence, it is a straightforward approach to a problem. So, whenever we want to solve any problem using the algorithm, first approach comes to our mind is brute force. Next comes the recursive algorithm. Recursive algorithm is based on the recursion. What does it mean? Means a problem is broken into several subparts and call the same function again and again. Recursive means what? Calling a same function again and again within a program. It continues. Why it calls? Why it calls again and again? Because it continues to do so until it searches a base case. Until it searches a base case that terminates the functions provided the given conditions are met. Until the condition. Some condition if we are given means until the condition is met, the function is called repeatedly within a program. Hence we say recursive algorithm. Next algorithm we are talking about or discussing is backtracking. It builds the solution by searching among all possible solutions. It searches among all possible, whichever the solutions are available, it searches. Whenever a solution fails, what does it do? As the name itself tells, backtracking, it traces back to the failure point. So, in our childhood days, our parents would say, tell the tables of 8, 9. If we keep on telling 8 ones are 8 ones are 8, 8 twos are some 8 threes are. If we stop there till 8 fours are, next we will again go back to the 8 ones are. So, like that, this backing track algorithm will works. So, it builds on the next solution and continue this process till we find the solution or all the possible solutions are look after. Searching algorithm. So, that are used for searching elements or a group of elements from a particular data structures. So, it will search for the key element in an array. Next, we will move on to the sorting algorithm. So, sorting means what? Arranging a data in a particular manner according to the requirements. Whether we require in increasing order or decreasing order from alphabetical like A to Z or Z to A. So, it will arrange according to the requirement. So, which help in performing this function are called sorting algorithm. Next, we have hashing algorithm that works similar to the searching, but they contain an index with a key ID. In hashing, key is assigned to specific data. So this hashing algorithm performs same as the searching algorithm. Next we have divide and conquer algorithm. This algorithm, divide and conquer, the name itself is telling. This algorithm breaks the problem into sub-problems. Divide, solve a single sub-problem, conquer, and merge the solution. Okay, and combine. So to get the final solution, it consists of divide, solve, and combine. How it works? Divide, solve, and combine. Example, we have merge sort, quick sort, and binary search. Next, we have greedy algorithm. So this type of algorithm, the solution is built part by part. The solution for the next part is built based on the immediate benefit of the next part. Example, Prim's algorithm, Kruskal, and Dijistra's. So these algorithms uses the greedy technique to solve the algorithm problems. Next, we have steps for writing an algorithm. Algorithm is a procedure, as we said, isn't it? It is a step-by-step procedure. It's a procedure that has two parts. How many parts? Two parts. So that is a head section and a body section. The head section consists of keyword algorithm. See here, the head section should consist of, this is the example, algorithm. The name of the algorithm with parameter list. This is the name of the algorithm. These are called P1, P2, etc. are called parameter list. Next, the head section also has the following, that is problem description. So what you are going to do, what you are doing, what is this problem, what type of problem is this. Next, input, what input you are providing to solve the problem. Next is what output you are getting. In the body of the algorithm, various programming constructs like if, for, while, and some statements like assignments are used. So these if, while, for, so these keywords we can use to construct a program. To execute a compound statements in a program, we are using if, for, while, and some statements, and assignments also we can use. Steps for writing. We will continue with that. The compound statements may be enclosed within open and closing the flower brackets. If, for, while. So these conditions are inserted using the opening and closing of the flower brackets. Can be closed by the end if, end for, end while. So if, for, and while, these are opening, and end if, end for, end while are the closing of these keywords. Next, comments are written using double backslash at the beginning. So this, for example, adding two numbers. This is for user reference. This is for user reference. The identifier should begin by a letter and not by a digit. It contains alphanumeric letters after first letters. No need to mention data types. The left arrow, this is used as a assignment operator. So if I am assigning A is equal to 10 in a programming language, but in an algorithm, we are telling A back arrow 10. So which means we are assigning a value 10 to a variable A. Boolean operators, true, false, logical operators like and, or, not, and the relational operators are used. Input and output can be done using read and write. So these are some of the steps we are following to write an algorithm. Next, we have a simple example here. Euclid's algorithm to find GCD of M and N, that is greatest common divisor of M and N. See, algorithm, the name of the algorithm and the parameters. So next follows the double backslash. So this is for user reference. What algorithm you are writing. So I am computing GCD of Mn by using the Euclid's algorithm. Next, what you are giving in the input? Two non-negative numbers and non-zero numbers. Next, what output you are getting? That also you have written in a double backslash. This three statements are for user reference. User reference. So what does the output says? You are getting GCD of m and n. So let us look into the algorithm, how it works. While n not equal to 0, what you should do? M mod n. You do m mod n. What is the remainder comes? You assign as to the remainder. If n is greater than m, then initialize the n value to m. If not, if m is greater than n, so you perform this operation. After performing, if n is equal to 0, then return m. So this is what our algorithm says. Let us show you a simple example. Here I am taking GCD of 24, 12. I need to find GCD of 24, 12. So what is the value of m here? 24. So n value is 12. So here m is greater than n. Then no problem for me. What I need to do? I need to perform the GCD using this formula. That is GCD of n. What is the value of n? 12, comma. So then mod m comma n. Mod m comma n. What is that? 24 comma 12. What is the result of mod 24 comma 12? 24 divided by 12 is, the remainder is 0. The remainder is 0. So I am writing GCD 12 comma 0. Now the m value is 12 and n value is 0. If n value is 0, what I should do? I should return m. Just write GCD of m comma n, that is 24 comma 12 is equal to 12 is the answer. So what is the answer? 12 is the answer. By using a mathematical, we can calculate, isn't it? So what is the GCD? How we are going to calculate for 24? For 12, 2, isn't it? So 2 into 2 into 2 into 3. Here 2 into 2 into 3. So 2 into 2 into 3 and 2 into 2 into 3. 2 2s are 4, 4 3s are 12. So I am getting 12 is the answer. Yes, this is correct. The Euclid algorithm works well. So we found out the answer by using the Euclid's algorithm. We find the greatest common divisor for the two numbers, that is non-negative integer, that is 24 and 12, and we found the answer as a 12. Yes, the Euclid's algorithm works well. Now, we will next move on to the advantages and disadvantages of algorithm. Till now, we studied what are algorithms, then what are the characteristics of algorithm, and we come across some of the problems which we are using in the further units using the algorithms, and what are the important algorithms we are going to study, and some of the characteristics we come across. Now we will look into the what are the advantages and disadvantages of algorithm. So advantages, it is easy to understand. Yes, it is easy to understand. So as I wrote, read A and B. Yes, you understood. I also understood, isn't it? It is easy to understand. An algorithm is a stepwise representation of a solution to a given problem. It is a stepwise representation, isn't it? I wrote 6 steps to add 2 integers. In an algorithm, the problem is broken down into smaller pieces or steps. Hence, it is easier for the programmer to convert it into an actual program. So, dividing a large problem into a sub-problems and finding solution to those sub-problems, again combining those solutions and getting a result is very easily. So, that is one advantage of the algorithm. Next, we will discuss about what are the disadvantages. So each and every thing has advantages and disadvantages. So like that, algorithms also some disadvantages. So writing an algorithm takes a long time. So it is time consuming. Understanding complex logic through algorithms can be difficult. So this is a plus b. Adding two integers is very simple. But when we come to the artificial intelligence or machine learning or a real-time applications, the understanding of the algorithm will be more difficult for us because we need to write a number of pages of algorithms. So it takes more time to analyze. Next, branching and looping statements are difficult to show in algorithms. So using branching, looping statements like if, else, while, do, while. So it will be very difficult. So these are some of the disadvantages of the algorithm. Next, we will move on to the fundamentals of algorithmic problem solving. So what are the fundamentals we require to solve the problem? Firstly, we need to understand the problem. So what is the problem? You should have some doubts within you. You should ask the question yourself. You need to understand the problem. Then after that, you need to decide the computational. Means, computational means it depends on the processor or time. Computational. How much time it is taking to execute, how much space it is occupying. So depends on the input of your algorithm, it decides the computational devices. Then whether you are getting exact or approximate solving algorithm, whether you are getting approximate result or exact result to that algorithm. Then design the algorithm. So after coming from the conclusion of these things, next you go to the design of an algorithm. After designing, you should prove, right, whether it is correct or not. After proving, you need to analyze how much time it is taking and how much space that comes under the analyze. Next, coding the algorithm. That means using a programming languages. Let us discuss one by one deeply now. Firstly, understanding the problem. So this is the first step in designing of the algorithm. So read the problem description carefully and understand the problem statement. So if I have given a problem statement, add two numbers, if you are doing the subtraction, then what is the use? Isn't it? First, you read the description carefully. Next, ask the question for clarifying. So if I add these two numbers, whether I am getting a greater number or smaller, like that, you ask a question by yourself. Next, identify the problem type and use existing algorithm to find the solution. Next, decision making is done on the following. The next step. So after understanding the problem, next is a decision making. The capabilities of the computational device. As I said, computational device means like a processor and a memory. So these two are mainly based on space and time efficiency. Next, choosing between exact and approximate problem solving. So an algorithm used to solve the problem exactly and produce correct result is called exact algorithm. Or if you are getting a approximate value as a output, then we can say it's a approximate algorithm. Next, methods of specifying an algorithm. So there are three ways to specify, to write an algorithm. One is natural language. Natural language is nothing but in which language we are communicating. Example, English language. It is easy to specify, isn't it? So natural language, it is easy to understand and specify. First step, I have read the first number, say A. Yes, you also understood, I also understood. Next, read the second number, say B. Then add above two numbers. What you should do? After adding, I am telling, store it in C. Store it in C. Next, after storing, display the result from C. So this is how I am writing steps in a natural language. Next, I have a pseudocode. What do you mean by pseudocode? It is a mixture of natural language and a programming language construct. So pseudocode is usually more precise than natural language. Next, we have here algorithm sum a comma b. How we are going to write? Algorithm sum a comma b. Next, double backslash we are using for the problem description. So this algorithm is going to do the addition of two numbers. Then what input you are going to give? So two integers, that is a and b. Next we are getting a output. What we are getting? Addition of two integers. That I am storing it in a c, variable c. So then return the value, whatever the result stored in the C, that you need to return. So this is how I am writing a pseudo code for the adding two integer numbers. Next comes the flow chart. It is a graphical representation of our algorithm. So it is method of expressing an algorithm by a collection of connected geometric shapes. So in the first slide we discussed regarding the geometrical problems. In that I said, so using the geometric shapes we are going to solve many algorithms. So see, now it comes connected geometric shapes and containing description of the algorithm steps. For each one steps we are using different geometrical shapes. Let us now discuss one by one. So the oval symbol to represent the start and end of a process. See how they are represented? Start and end of the process. So oval is used. Next comes the rectangle. So it denotes a process or operation. What you are doing. It tells what operation you are going to do. The arrow tells or indicates the flow between steps. From one step to another step, the arrow indicates the flow to where it is flowing, from up to down or down to up. Next, the diamond shape. The diamond, it signifies a point requiring yes or no, whether it's getting output or not. Next, parallelogram. So what is it, parallelogram? It is used for input or output operations. See, for input A and B I have used a parallelogram, and for the output print sum I have used a parallelogram. This is how we depict the flowchart for a program. Next we have proving an algorithm correctness. So we need to prove, isn't it? Once an algorithm has been specified, its correctness must be proved. That is analyzing an algorithm. So to analyze an algorithm, the four main factors considered, that is time efficiency, space efficiency, and simplicity of an algorithm, and generality of an algorithm. So what do you mean by time efficiency? It indicates how fast the algorithm runs. Next comes space. How much extra space it is going to use. Next, coding an algorithm. The coding, implementation, algorithm is done by suitable programming language like C, C++, Java and Python. By using these programming languages, we can implement our algorithm code. Next, it is very essential to write an optimized code to reduce the burden of the compiler. So as I said, if I am adding two numbers, why need to take C? If I take a C, that will be confused for the compiler, isn't it? So that is waste of space, that is waste of time. So these are some of the methods of specifying an algorithm. Next comes fundamentals of the analysis. We need to analyze. The efficiency of algorithms always we will tell in the terms of time and space. Algorithm efficiency can be analyzed by the following ways. That is analysis framework, asymptotic notations, mathematical analysis of recursive and non-recursive algorithms. We have next analysis framework. The research experience has shown most problems we can achieve much more spectacular progress in speed than in the space. They have shown, many of the researchers, they have shown that most problems can achieve more spectacular progress in speed than the space. The algorithm analysis framework consists of the following. We have to measure the input size, then measuring the running time, order of growth, worst case, best case, and average case. We need to study all these things to analyze the algorithm. Next, we have measuring an input size. We need to measure the input size. When we measure the input size for algorithms solving problem, that is checking primality of a positive integer n. To measure size by the number of bits in the nth binary representation is given as b is equal to log n to base 2 plus 1. If I am entering a, so it takes it in a bits, isn't it? So that nth binary representation is, we are representing the space complexity like this, log n to base 2 plus 1. Next, running time. Some standard unit of time measurement such as seconds, milliseconds, and so on. So how many time it took to execute an algorithm. So we will measure it in a seconds, milliseconds, and so on to measure the running time of a program. Established framework for the analysis of algorithm time efficiency suggests measuring it by the counting number of times the algorithm's basic operation is executed on input of size n. So here we have given a size a, isn't it? We have entered a character a. So it has taken a nth binary representation. So that they are going to execute input of the size n. They are measuring the running time for the input of n values. Next is the order of growth. The order of growth of an algorithm is an approximation of time required to run a computer program as the input size increases. If the input size is small, the execution time is also very small. Within a milliseconds, you will get an output. If input size increases, the execution time also increases. So based on this, we can calculate the order of growth. The change in the behavior of the algorithm as the value of n increases is called order of growth. So n is nothing but the input value. Okay. So the changes of a behavior algorithm depends upon the value of n, that is input value. Next we have worst case, best case, and average case efficiencies. So in the worst case analysis, the efficiency of an algorithm for the input of size n, we are taking input of size n, which the algorithm takes longest time to execute among all possible inputs, that we will call it as worst case. In the worst case analysis, we calculate the upper limit. So in the worst case analysis, we are going to calculate the upper limit of the execution time of an algorithm. Next example we have, here we have taken a linear search as an example to calculate the worst case. See, if I have 5 numbers in an array, say 5, 4, 3, 1 and 10. If I have 5 numbers in an array, my key element to search is 2. My key element is 2. So, if I have entered an element, I know the 2 is not present. But the machine doesn't know, isn't it? But it checks from first number. Its index starts from 0, 1, 2, 3, 4. Isn't it? It's a n minus 1. It searches from a first element. Searches begins. So, 1 by 1. After checking 5, not found. Then 4, then 3, then 1, then 10. So, it searches all the element to get the key element 2. So, to search for its not present in the array, when x is not present, the search function compares it with all the element of array 1 by 1. Therefore, the temporal complexity of the worst case of linear search is theta of n, because we are giving n number of input. That's why we are telling theta of n is the time complexity of the linear search in the worst case. Next, we will move on to the best case analysis. So the efficiency of an algorithm for the input of size n for which algorithm takes least time. Okay, so this is how we say it is a best case, least time. So for example, I have taken 5, 4, 2, 1 and 10, isn't it? So if my key element is 5, so it is present in the first index itself, isn't it? In the 0 index. Yes, it will check the first number and test found. So it is a least time. Then we will say that it is a best case analysis. Next, we have average case analysis. In the average case analysis, we talk all possible inputs and calculate the computation time for all the inputs. For linear search problem, assume that all cases are uniformly distributed. So, we can say divide sum by n plus 1. So, if we have, for example, 5, 4, 2, 10, if my searching value is 2. So, in the middle, the element is present in the middle, then we can say it is a average searching time. So, it taken a average time for searching a key element. So, this is how we come across the average case analysis. This is how we do the average case analysis. So, this is, we are come to an end of this unit 1 session. In this session, we discussed regarding the introduction, that is what is the algorithm, what are some of the characteristics, properties, and we come to know which are the areas we are going to use the algorithm. Some of the problems we discussed, we come across advantages and disadvantages of the algorithms. Then we studied about the algorithm problem solving. Next, we find out the algorithm efficiency, that is what is the running time, how we need to calculate. Then what are the worst case, best case and average case efficiency. Then order of growth. So all these things we discussed in this session. In the next session, that is unit 2, I am going to discuss regarding the asymptotic notations and basic efficiency classes. Then mathematical analysis of recursive and non-recursive algorithms. Thank you.